So the first one was, so I had a 6-node communication network, and I wanted to, and this communication network we saw in class also, so let me just draw that. That is source, here R1, R2, and for this 6-node communication network, I said the first question was, 3A was, list all routes from node S to node D. So list all routes. So then first thing first thing you need is a definition of a route. A route is a sequence of a route between two nodes is a sequence of relay nodes connecting the two nodes. So, and usually you consider the source and destination also as part of the route. So one simple route from S to D is S, R1, R3, D. So that's one. So let me write that here. Now another route is S, R2, R4, D. So as you can see, if you just look at this picture, you see that it is symmetric along this axis. That is, whenever there is a route which goes through R1, S1, because there are only two possibilities for the first step. It can be either R1 or R2. So if there is a route which goes through R1, there is a corresponding route through R2. So which means that if I list all the routes which go through R1, then I just flip the indices. That is, I replace R1 with R2. Like in this case, I replace R1 with R2. R3 with R4, then I get the corresponding route which passes through the R2. So let me just do the listing for the top now. So this was one route. Then the other route is, I could go S, R1, R3, R4, D. And then the corresponding thing would be just replacing S, R2, R4, R3, D. You check if that makes sense. So SR2, R4, R3, D. The other one is, then there is one more routes ahead. Then SR1, R2, R4, D. And SR1, R2, R4, R3, D. And the corresponding routes for R2. Let me just write SR2, R1, R3, D, SR2, R1, R3, R4. Yeah. So these were the routes which most of you wrote, and there was only one person who noticed the symmetry and took advantage of that. But these routes, they all have some property. So most of you did not consider the case when loops are allowed. That is, I could go S, R1, R3, R4, R2, R1, R3, D. So that is a loop. So what you actually listed was loop-free routes. Or which are also called paths. So this is fine. So I give credit for anybody who came up with these 8 routes, but remember that my definition was not restricting the routes to be loop free. Of course, you can argue that it doesn't make sense for a route to have loops, but such routes can happen in practice where in real life the network is so complex that loops may occur. and a good routing algorithm will get rid of those loops, but an intermediate stage may a route which is still being optimized may still contain a loop. So there's only one person who identified that loops are possible, but I gave full credit for anybody who came up with these loop-free routes. So that was 3A.